The problem we're going to be solving is to find the equivalent resistance in the circuit below. We can see that there is a 7 ohm resistor, a 4 ohm resistor, a 2 ohm resistor, and a 3 ohm resistor in this circuit. Now when adding equivalent resistance, we have to remember the two equations. For doing so, for series, we just simply add the resistance of each resistor. So the equivalent resistance is R1 plus R2 ongoing. And for parallel resistors, it is 1 over R equivalent equals 1 over R1 plus 1 over R2 ongoing. So these are the two equations we're going to be using to solve this problem. Now by looking at the circuit, we can see that the 4 ohm resistor and the 2 ohm resistor are in parallel. And the easiest way to solve this problem is to find the equivalent resistance of those resistors first. So we simply do 1 over 2 ohms plus 1 over 4 ohms is going to equal 1 over the equivalent resistance, which is 3 over 4 ohms. And the reciprocal of that is 4 thirds ohms for the equivalent resistance of the 4 ohms and 2 ohms resistor. Now, because the equivalent resistance of these two resistors is now 4/3 ohms, we simply have a circuit with 3 resistors in series. And if we go back to our equations that we had, we can see that we simply just add the resistance of each of the resistors in the series. So that's 7 ohms plus 4/3 ohms plus 3 ohms equals 34 over 3 ohms, which is approximately 11.33 ohms. And that is our total equivalent resistance in this circuit. Now, a common error that many students have when solving this problem is that they simply just add the resistance of each resistor. And if you do that for this circuit, you get 16 ohms, which is much larger than the 11.33 ohms that we solved for the problem. So you have to remember to use the equations and solve correctly for series versus parallel.